Welcome to this lesson. We are going to discuss the process scheduling. By the end of this lesson, everyone will be able to explain what scheduling is, able to explain scheduling queue and deadlock, and everyone will be able to explain scheduler and all types of scheduler. Let's start by defining what is a scheduling. The process scheduling refers to the order in which the resources are allocated to the different processes to be executed. Here we have to remember that a process is any program in execution. Each process has to take part in CPU so that it can be executed. So the process may require some resources, and the resource may be available or unavailable. So it's the process scheduler which will decide whether the process will continue to be executed or it can be stopped so that the resource can be available. Process scheduling is done by the process manager by removing learning processes from the CPU and select another process on the basis of particular strategy. So we have a program called Process Manager, which decides which process to be executed next and which process has completely executed and be removed from the CPU so that another process can take place. Remember that only one process is executed at a time in the CPU. While the process is being executed, there may be many processes waiting to be executed. So we are going to talk about scheduling queue. The scheduling queue is a queue that keeps all the processes in the operating system. You may have 5 or 3 or 10 processes which are waiting to be executed. So in that case, the operating system is going to create a queue of all processes which are waiting to be executed. The operating system maintains a separate queue for each of the process states, and the PCBs of all processes in the same execution state are placed in the same queue. We are later going to discuss about the state of the processes, and the operating system is going to place each process in its a queue according to the state the process is. When the state of a process is changed, its PCB is unlinked from its current queue and moved to its new state queue. Here we have 3 types of queues or scheduling queue. We have job queue, we have ready queue, and we have device queue. The job queue is the queue that keeps all the processes in the system. When you launch any program, it goes on the job queue. Any program launched is going to go on the job queue, and we call this a job queue. A ready queue, this is the queue that keeps a set of all processes residing in the main memory, and these processes are ready and waiting to be executed. A new process is always put in this queue. So you launch a program, then this program will be placed on the ready queue when it is waiting to be executed. We have a device queue, which is a process that is blocked due to unavailability of an input or output device constitute this queue. So in the device queue, there are sometimes a process require an input or an output resource so that it can complete. When the device or input or output device is not yet ready, so the process will not remain in the CPU. It will be blocked, be put in the device queue until the input or an output device get ready so that the process can continue the execution. On the diagram here, we are going to see how it works. All jobs, any program which is launched is placed on the job queue. Then it is from the job queue going to the ready queue. The CPU will get all the processes from the ready queue, nowhere else. There may be a case, the process, let's say a process P1, a process P1 is being executed in the CPU. Then this process P1 needs an input device. Let's say it needs to activate a camera. So while the camera is being called or launched, the process P1 will not remain in the CPU when there are other processes on the queue ready to get executed. So the process will be swapped out, will be removed from the CPU, another process will take place in the CPU, then that one will go in the input and the output waiting queue. Then when the resource is available, then the process P1 is going now to be placed in the ready queue. Then it will continue when its time comes. When the process finishes, it's going to exit or to be terminated. There may also be a case where the process does not need any output and input device, but while it is being executed, there comes another process with a high priority. So in that case, this process will be removed from the CPU, then goes to the ready queue, and that one with a high priority execute. Once it finishes, that one which have been put in a ready queue will continue. So basically, this is how the process scheduling works. Each process should be in two main states. Each process should be in not running state or in running state. It is this process or these two main state is also called two process state model. So here we have a process which is opened, or which is new job which is created. That created job is not in running because when it is on the waiting list, it's in not running state. Then the dispatcher or the dispatch here, this dispatcher is a program which select the next process to be executed. So this dispatcher will go in not running database or list, then get the process, then send it to the running, so which means to send it to the process, and the process will change the state from not learning to the learning mode. The process may be in learning mode, then due to a high priority process which comes, that one can be paused before it finishes. So it will be removed from learning, then be taken back to the not learning. Then when that one with a high priority finishes, that one will come again. The dispatcher will take it again to the learning state. And when it completes, it exits. So those are the two possible state model for each process. Let's take an example. Suppose we have a process P1, which is created. Then when it is created, process 1 is in not learning state. When the CPU becomes free, the dispatcher gives control to the CPU to execute the P1. Then the P1 will change the state from not learning state to the learning state. Here the dispatcher is a program that gives control of the CPU to the process selected by the CPU scheduler. So the dispatcher is an operating system program which selects the process to be executed, then send it to the CPU. So when the dispatcher allows P1 to execute on the CPU, then P1 starts its execution. Therefore, it becomes in the running, it comes to the learning state. If a process P2 with high priority want to execute on the CPU, then P1 should be paused, or P1 will be in the waiting state, and P1 will be in the learning state. When P2 terminates, then P1 again allows the dispatcher to execute it on the CPU. However, there may be abnormalities in the learning state of processes whereby they block one another. So you may have a case where there are two processes of high priority, and each one want to take place first. So in that case, there will be an abnormality that we call deadlock. The deadlock, this is a time where the two processes or more processes block each other. So what is deadlock in detail? The deadlock is a situation where a process or a set of processes are blocked, waiting for some resources that are headed by some other waiting processes. Here, a group of processes are permanently blocked as a result of each process having acquired a subset of the resource needed for its completion and waiting for the release of the remaining resource held by other processes in the same group. So this makes it possible for any of the processes to proceed. So the deadlock here is a process or a situation where two or more processes are fighting to have access on the same resource. So for example, let's take an example where there are two trains which are coming toward each other on the same track. And there is only one track. None of the train can move once they are in front of each other. So what will happen? There is one way and two tracks